Hello friends, welcome to my channel. Let's have a look at problem 298, binary tree longest consecutive sequence. In this video, we're going to share a treatment based on recursion. First, we'll read through the statement to digest the problem requirement, and then we do the analysis and share the code. First, the statement. Given the root of a binary tree, return the length of the longest consecutive sequence path. So here, a consecutive sequence path is a path where the values increase by 1 along the path. And note that the path can start at any node in the tree, and we cannot go from a node to its parents in the path. In other words, we can only go downwards, right? So let's look at the two examples here. So in example 1, so the output is 3, and the corresponding longest consecutive path is 3, 4, 5. So in example 2, so the output is 2, so the corresponding longest consecutive path is 2, 3. So notice that we have another pseudo consecutive path, so starting from 1, then to 2, and 2, 3. However, this is in the reverse direction, which is not codified. So in this problem, we are going to return 2. So with the examples went over, let's look at the constraints. The first constraint is on the number of nodes. So it's between 1 and 3 times 10 to the power 4. So in particular, the tree is not null, right? In other words, our return is at least 1, right? Because we have at least one node. The second constraint is on the node value. It's in a range given by the negative 3 times 10 to the power 4 and its absolute value, that is positive 3 times 10 to the power 4. So in particular, the node value can be 0 or negative. So with that said, we are ready to look at the treatment. So here the treatment is based on recursion. So recursion here is very natural. So if we consider the 2 points below. First, the binary tree as a abstract data type, it's recursive in nature, right? The second one is the problem logic. So this will be made clear in the coding. So let's look at the idea. So the idea actually is very straightforward. So for each node, we're going to compute 2 pieces of information. Compute 2, right? No, not 2. We can call them L and R. So in other words, we want to write a function. Let's call it F. So it returns 2 pieces of information, L and R, where L is the longest consecutive path length starting from node towards left, and R is towards right. So this way, at each node, we could find the longest consecutive path stemming from that node. So this length is nothing but the max of L and R. So we just need to update this quantity during our traversal of the tree in order to return the result. So as to how to get LR for a node, so this is actually very straightforward. So if we initialize F node to be 1, 1, in other words, R equals 1 and L equals 1, then if node left exists and node left value is 1 larger than the node value, so we are going to update L by L increment by max LL and LR. In other words, the longest consecutive path length stemming from the node left, right? So you can interpret LL and LR as L and R information for node left. So similarly, we can do the update for R by considering the right subtree. So in the recursive process, we just need to update the quantity max LR for the result. So with that said, I guess writing the code is straightforward. So now let's look at the coding. So in order to do the continuous update, I'm going to introduce an attribute. Let's call it result. So I'm going to initialize it as 1 due to the fact that the root as a tree is not null. And then we're going to look at the hyperfunction. So I'm going to accept a node. So I'm just use this as a root. just for convenience. So you can write it here node. So so we use root so that we can write the left subtree and the right subtree. So let's first treat a special case if not root. So we're going to return 0, 0, right? So this is a stop condition or base case for the recursion. So next I'm going to set L and R to be 1 and 1. In other words, currently we the path only containing the root node itself. And then let's check if root left. So in other words, if we have a left subtree, then let's first get information for the left subtree, right? Root left. And then we're going to check if root value plus 1 equals root left value, right? So in this case, we can connect the root with the left subtree root. So this way we can update this L to be incremented by max of LL and LR, right? So this is the one case. So next we're going to check root right. So in this case, so we're going to get RL and RR to be F root right, right? So now we want to check if we can chain the root with the right subtree together by considering the consecutivity, right? So root value plus 1 equals root right value. So this expression here, root right value, is meaningful because it's at this if block. Similarly above for root left value. So now if this is the case, so we're going to increment R by max RL and RR, right? So this way we have found the information LR for the root, and then we're going to update our result. Self result is going to be the max of its previous state and the max of L and R. So max L and R is the longest consecutive path stemming from the current root, right? So that's actually the logic. So we're going to return L and R. So this is the hyperfunction. So next we just need to call the function. So I call froot. So this actually is going to return L and R, but we do not need them. So actually we can do this if we like, or we just write froot. And then what we're going to return is self result. So this is the final state of this attribute. So with that said, so we are ready to do the check. Yeah, it passes one example. Now let's look at generic case. Right, it passes all the cases. So let's check again. Yeah, it passes all the test cases. I guess for this problem, so that's about it for the coding. So you are welcome to check out other videos in my channel or playlist for explanations on algorithms and Leetcode problems. With that said, I guess that's it for this video. Thank you.